Hello everyone, I'm now working on a machine learning project and I'm using Python and scikit-learn to predict prices for real estate properties. Here is the data set I have. So this is data from Artadam website, which offers us the Polish real estate properties. All the advertisements are like available from now and to whatever active so far. So first, let me just show you what the data set actually looks like, and then we'll walk through the steps like essential to create a model that would be predicting the prices. Okay, so I just start with starting the Python shell here, and I say import pandas as PD, and I want to create the data set by saying pd.readcsv and autodom.csv. Okay, so here yeah, it's quite huge and it takes time to load. So if I say data, we have 97,563 rows. Not all of those are actually being used, but anyway. So let me show you the data info here. So like we don't even have price. But notice the characteristics column. It's type object, and we would be extracting most of the features from the characteristics. It's not really feature engineering because we're not creating any new features here, but those available under the characteristics are quite important. Then the essential ones are the latitude and longitude. So let's have a look at those characteristics we can make use of. So if I say data and characteristics, and just to print all of them, I just use apply here and the lambda function, so x, and I just want to print. Let's just give it a new line, then the x itself, and then again the new line. We don't quite need to print all of those, but anyway, just scroll through the entire data set. And once it's done, so here you see like we have the price of the area in square meters, like 57.9 the last row. We have whether it's the primary or the secondary market. um, then yeah, lots of useful stuff here, like the build year, number of rooms, etc. So our goal is to extract this data from the characteristics, and let's just create file here. So I just say let's call it autodom.py. So we are going to be training our model here. So traditionally start with importing some packages. So I want to say import numpy as np because we are going to be doing some scaling with our data. Then import pandas as pd to load the data set, to work with it. Then from sklearn dot model selection, I want to import train test split. So we will be splitting data into the training and testing sets. Then from sklearn dot ensemble, want to import the random forest regressor. So this is the regression task. We're going to be predicting the prices, right? And also from sklearn.metrics, want to import mean absolute error. Okay, let's make sure that it works. So autodom.py. Okay, yeah, everything works. Nice. So the next step to do, is probably like before anything else, since there would be lots of similar tasks for pre-processing our data, so we'll end up creating a function for that purpose, and the function is going to be working with a copy of the data set. So by default, it will be giving us a warning that we are actually working on the copy. So to disable that warning, we want to allow working with data frame copies. So here I want to allow working with data frames copies, and I just say pd dot set option and mode dot chained assignment chain assignment, and just none here. So let's make sure so it works. All right. Now time to load our data set. So load data from CSV. So data equals to pd read CSV, and I'm using the same autodom.csv file that we just inspected. Okay, and now the function, the main function for like working with this data would be the function to pre-process data, or let's better say like extract features from characteristics. Okay, so def, I just call it preprocess data, and this is going to be taking the data set, just call it data, and also would be taking the feature that we are referencing and the split string. So what is the split string? The split string is the string we're supposed to be split into characteristics by to extract the proper one. We could have used the JSON parse, like JSON loads, to convert that into the Python dictionary and then reference elements by indices and the keys for a given one. But since the data is not structured and there might be some missing values, this is not working that smoothly and like needs some additional preprocessing, which I don't really want to spend time on. So I'll just go straight forward and be passing the string directly. So hopefully that makes sense. So what we want to do here, we want to say data indexed by the given feature is going to be equal to data. Now we're referencing our characteristics, and want to apply to every single row of the characteristics the following stuff. So again, I'm just using the lambda function here, so lambda x. And what we want to do here, lambda, okay, what we want to do, we want to say x dot split, and we split in by the split string, and we're using the very last element, right? And then want to split one more time because we need everything that goes before the single quote and take the element 0. And eventually we want to return our updated data set. So to call this, I say data equals pre-process data, and I'm using the existing data set, and I want to use price as the feature, the target feature, and also price as the split string. So if we now try to run this, and hopefully the prices would show up. They still would be just the strings. Yeah, it doesn't seem to be the very appropriate. Yeah, it still prints pretty much anything here. Okay, I don't want to print, obviously I don't really want to print the characteristics anymore. I just want to print the price. Okay, and here the prices should already be extracted from the data set. Okay, not really. Yeah, okay, that's just because I didn't specify the split string properly, so this should be like this, and here just say price, and yeah, now this should work. Okay, seems like we have the prices, but the problem here is that not all the prices are actually available. So see like the blanks somewhere, so we need to get rid of those. So the next step to consider is the following. So I can say, so I need to filter the data, so I need to filter like drop not available, drop those elements that are not available. So here are just add some more commentary. So here want to extract feature. Okay, here we want to drop not available ones. Okay, values, let's say. So I can say data equals to data and the filtering, the following, the filtering conditions of feature. So it's not equal to the empty, empty row. Okay, now it should not bring the empty line, so it should like take them away. Okay. Okay, so it drops down, which is really good. Another thing to do, we actually want the data to be turned into the floating point type. So to do this, I just add the try except thing here. So for now, except is going to be passed, but when it comes to one-hot encoding features like whether it's the secondary, the primary market, and so on, the heating maybe, like and the rest of features that would be like Boolean, but it would be having the Boolean values. We'll add some more code here where the pass is, but for now, I just want to say, so I want to try to say data for the given feature is going to be equal to data. So feature is not it's not the name, it's just the variable, and I want to say as type and float. Okay. All right. So now instead of printing the entire stuff here, I just say print, and let's say data and price, and I can use the value counts, for instance. Let's have a look. Now to deal with the rest of the features we're about to be extracting, I also need to add some stuff here. So let me just quickly paste the code in. So we want to replace essentially this Garrett by 1, seller by 0, floor higher than whatever value with nothing here. The ground floor should be equal to 1. So the values within the characteristics might not always be just the pure numbers. So we just get rid of whatever characters, and if we don't encounter the certain characters, this might be just returning this parenthesis here. So this part is sort of universal for all the features we're supposed to be extracting. So it's not just for one type of characteristics. So all the characteristics we're supposed to be extracting are combined here. You can just try adding more characteristics, and it would be giving you errors like Garrett cannot be turned into the floating point and so on. So that is like to give an idea like which particular pieces to get them replaced. But yeah, just to save time, I just put the code in and work from here on. So generally here we want to extract features from extract features. Yeah, and let's do some more. So what else do we want to do? So let's extract the floor. So want the floor, and the split string is floor number. Then we want the area, and the split string would be just M. And then we want rooms. and rooms would be rooms num. And finally, let's do also the, it's not this one, let's also do the year. So year, and here we have the build year, right? And let's also print the value counts for the floor. Well, we could actually, I don't know, yeah, we could, let's just do one for the floor. Then for the area, well, let's actually go one by one, yeah, because there might be some issues. So let's just see. So now the floor, right? Okay, we got the floor. Great. Then let's do the area. Let's see what we have in the area. Okay, we got the area as well. So check out the rooms and the year. Rooms. Okay, and finally the year. Okay, let's have a look at the eventual data set we came up with so far. So if I just print data, turns out that lots of redundant things are still there, and yeah. And since it doesn't even print all the features we want, so let's drop back and say again data and just info here. So remember that in order to apply the dataset, in order to apply the machine learning algorithm towards the dataset, we need to make sure that all the values are numeric. And those we have objects, we actually need to drop those and only leave those, like in our case, this is the float 64 data type. So to do this, I can do the following. I can say just drop redundant features, and I say data.drop, and here there would be the list of features to drop, and I want to say axis equals to 1 and in place equals to true, right? So we do this within the data set itself, and I just bring in some features that we don't quite need anymore, so those that represent the object data type. And let's have a look at the info. So here I want to print eventual data set. Right, quit. So look. Okay, so we have the latitude, the longitude, the price, the floor area, rooms, and the year. Although these are not all the features we're supposed to be using for this model, still this is already enough to build the very initial model and to evaluate its performance. So let's go for it. So here I want to say the following. First, we want to split data into source features and this conventional name x, and target variable which has the conventional name y. So I say x equals to, and I say data dot drop, and I want to drop the price. I want to drop the price, and x is equals to 1. And for the target variable is going to be called data price. So just to give you an idea one more time, so we say print x, and also let's do print y. So x has all the features but the price, and those are the source features we're supposed to be using for prediction, while the y, the target variable, is the actual prediction target, which is price. So we see like we have all the columns above and only the price below. So hopefully that makes sense. Once this is done, the next thing to do, want to split data into training and testing sets. So I can say x train and x test, and then y train, and then y test equals to train test split. And we use an x, y, the test size is going to be equal to 0.2. So we have 80% for the training data, while 20% for the testing data. So we'll use only 80% of the data to train the model, and the rest 20% to evaluate the model by like predicting the values for those 20%. Hopefully that makes sense. And also I want to say the random state equals to conventional value of 42, because this simply allows us to like randomize the data within these sets. All right, so next thing to do, want to define the model. So define model, and model is going to be equal to a random forest regressor. So one of the most common algorithms for house prediction, actually. Also decision tree works, but random forest just uses lots of decision trees and generally just works better. Okay, we can also define the random state to have the exact results. Let's just do 42 for now, and we'll change the number of estimators, like how many decision trees to use, literally, a little bit later. For now, just want to train the model, and I just say model.fit, and say x train and y train, right? And then we want to evaluate the model. So here, I just say y predicted is going to be equal to model dot predict, and we're predicting the test data, x test. Then I want to define the ACC variable. So this is the accuracy when we score the model using the training set. Doesn't probably make that much of a sense, but if we want to detect any underfitting issues, then this might be a good idea. So I just say model.score, and here I'm using x train and y train. But the actual value that we are really interested in, the eventuals of evaluation, is when we do the same, but let me just copy this quickly. So when we do the x test and y test, so this is going to be lower, but that's how the model is about to be like failing when it comes to the data it has never seen ever before, which makes it actually usable for the practical purposes. And finally, I want to calculate the mean absolute error, and just say mean absolute error, and here comparing the y test with the actually predicted y predicted. Now let me paste in some code that pretty prints the results and also prints the feature importance, which is quite an interesting insight when it comes to sort of decision tree stuff. And with this code being available, we can already go for testing. Fuck, it takes so long with video recording thing here. Okay, so we have the performance of 78% out of the box, and when it evaluates on the training data, even 96, which is fantastically good. But this still can be improved, and from now on, we will consider those steps that would help improving the model a little bit. Let's go and add some what is known one-hot encoded features. So here is the deal. So within our function to extract the features, we cannot yet deal with those features that don't have the numeric values within the characteristics. So say we want to preprocess one more parameter, which is the market. So whether this is the secondary or the primary market. So it's quite essential feature to add some value to predict the price. We have the market here. And also, I just don't really want to train the model. So here, temporarily, just say import sys and say sys.exit, because I don't really want to wait forever until it's done. And here it would now give us an error because the value for the market would be either primary or secondary. So let me quickly show you this. So if I run this again, would now give me an error. Yeah, okay, it doesn't print the error because I just pass silently there. So if I just do here, if I say accept exception as E and bring the exception here, it would actually tell me what's wrong there. So we are supposed to be adding some more conditions. All right. No, it doesn't even print anything for some unknown reason. Yeah, could not convert string to float, and the value is primary. Yeah, so that's the error. Great. So let's handle this as well. We can do the following thing here. So here under the except down below, we do the following. So just say except, and I'm going to be using what is known as the one-hot encoding. So the idea is simple. Say you have like the feature that might take the values like, well, in our case, this is primary and secondary, but there might be more than two values. There might be like building material, like is made of bricks, of concrete, concrete plate, or whatever, or the heating type, like gas, electricity, stove, whatever. So there might be many values. So each value is taken, and if that value is indeed the value for the given data row. In that case, we can one-hot encode it, which means turn it into either true or false. It's really easy to demonstrate rather than to explain. So I can simply say one-hot, and we say pd.get dummies. So this is the standard pandas way to deal with it. So data equals by the feature. So now those primary and secondary would actually be converted into the so just can print those. I just can print and one hot. And let me quickly demonstrate how this is going to look. Okay, the typo, yeah, and obviously I meant feature, not the features. Okay, so you see like this whole lot of true and false. Just to make it even better, I just could do one hot dot value counts. And down below for now, I don't want to print the data set. Yeah, and we have the values for primary and for secondary. So if I just do heat in here and the same split string, so heat in here, and also I want to add the construction status and here as well. And also I want to add the building ownership. Okay. And I don't probably want to print anything here for now. Just drop this. And I want to see the eventual data set. No, not here. The eventual data set. And we also want to drop these. So I want to drop the heating, construction status, and building ownership from here. So just want to drop heating. So heating with like the object values, we don't quite need those. Construction status and the building ownership. Okay, let's have a look. Well, we don't see any updates because we didn't actually join the updated one-hot encoded features. So let's quickly fix that as well. So here I want to say data equals to data.join and this one hot encoded thing. Okay. Okay, so here are the problems arising. So we have the overlap of the indices. So we have the index of 0 arising from somewhere that we don't really want to have. In other cases, I had the index other when other was under the heating and building material. But since I didn't drop the building material, that's probably not a problem anymore. But let's get done with indices to make sure that it's not going to be a problem. So sometimes it might happen. Here, I just want to say, try to say data.drop and the index of 0 along the axis 1 in place equals to true. And if you cannot do this, just don't do this. Okay, now we have some newcomers being added here. Okay, I have the 0, which I have no idea where it comes from, to be very honest. Yeah, so why wasn't it dropped? Not the data drop, but one hot drop, yes. One hot drop. Okay, now this already looks like a reasonable data set. So let's see whether these changes would affect the modal fit performance here. So I just want to get rid of these temporary string. Finally, let's do some hyperparameters tuning here. So I want to set the random state to 23, just performs better for some unknown reason. And also I want to say the n estimators, which is essentially a number of how many decision trees has been involved during the training process. I want to set these to 40. And let's do the final server run here. Well, okay, great. Now we have the accuracy of 81, so 81%, which is not really that bad at all now. So starting from here, probably one last thing to mention is the following. So if you need to improve the model even more, then what you can do. So first you can use the cross-validation and specify the grid of parameters, like not only the estimators and like the random state I use there, but like the maximal depth, there's like various split related parameters and so on, where you have like tons of parameters and this random forest regressor is running with all the possible combinations of those parameters. So this sometimes results in a better performance, but that's just a matter of fine tuning. If you have a poor data, this would not really help much. And somewhat a similar technique is can actually be used to play around with the actual features. I've been doing this manually, like basing on my intuition, basically, like trying to add more values, trying to get rid of some values. When it comes to the like binary one hard coded values, you can just say use all the values for, let's say, heating, but some heating types might not be appropriate and just potentially adding some random noise to the model, so you might want to get rid of those. Ultimately, you can write some code to automatically try various sets of features and compare the performance, but that's sort of a really time consuming task. And when we're talking about just very basic research and determining the potential of the current data set we actually have here and what performance we can expect from this sort of a data set. Well, okay, guys, at this point, the basic research is done and I'm no longer wasting your time. Thanks for watching. See you later and cheers.